Today we're continuing in section 5.1. We're verifying more identities. This is video part 2, and we're just going to keep looking at more examples. Now, take a second and refresh yourself with the guidelines that we have established for verifying these identities, just the suggestions we have for verifying them. Also, remember to go through and remind yourself about our reciprocal, Pythagorean, and tangent and cotangent identities. Now that we're ready to go, we're going to take a look at our first verification. We're trying to decide, we're trying to verify that 1 plus sine theta over cosine theta equals secant theta plus tangent theta. Now, the first thing, remember, we have to decide is which is the more complicated side. And it's a little hard to determine here because they both have a bunch of pieces. So, let's go ahead and just start with the left for now. I'm going to start with this left side. The 1 plus sine theta cosine theta. Now, it's a fraction, and one thing that's nice about fractions is when you've added them together already, you can also split them apart. I can split 1 plus sine theta over cosine theta into 1 over cosine theta plus sine theta over cosine theta. Now think for a minute about that. I can take the numerator and break it apart, but I have to give the denominator to both of them. And that makes sense because when you're adding fractions with common denominators, you add straight across the top and keep the denominator the same. Now, be careful for a minute because if it was the other way around, if it was cosine theta over 1 plus sine theta, you can't put cosine theta over 1 and cosine theta over sine theta. So this does not work with splitting up the denominator. It only works for splitting up a numerator. Okay, so be cautious with that. Be careful. All right, let's go back to where I started though. I have 1 over cosine theta plus sine over cosine theta. And let's take a minute and review our goal. Our goal over here is to get a secant plus a tangent. Well, the nice thing about 1 over cosine is that's the same thing as secant. So right now I have that secant that I'm looking for. And the other great thing about sine over cosine is that's the same thing down here as tangent. So I have secant plus tangent, and that's what I wanted it to equal. I wanted it to equal secant plus tangent. So we just went ahead and verified that identity. Now, some of you might be wondering, what if I had started on the right side instead? I think the right side is more complicated, so I want to switch my goal. I want my goal to be 1 plus sine over cosine, and I'm going to start with secant and tangent. You could do this the other way. You could say that secant is 1 over cosine, that tangent is sine over cosine, and now I have common denominators, so I can add straight across the top, keep the denominator the same, and I get the goal I was looking for. So you can see I could also verify this one the other way if I wanted to. It's not going to matter which side you start with. You should be able to make it look like the other side. It's just a matter of how much work and how much more complicated is it. In this case, either side you started with would have been just fine. Let's take a look at another example. The next couple examples are going to get a little bit harder on us, so be ready. I would have your highlighter out and be ready to highlight any steps you get confused on so that you remember to ask when you're in class. So, verify this identity, and we have it written right here. Let's bring that X over the C. it's pretty clear to me that the left side is more complicated than the right side. So we're going to start on the left. Now, if you remember, one of our guidelines after we start with the more complicated side is to combine fractions. So I want to add these two fractions together. Remember, to add fractions together, I need a common denominator. Now, if I look and I see 1 plus sine x as one denominator and cosine x as the other, I think the common denominator is going to be those two things being multiplied together. 1 plus sine x times cosine x. That's going to be my common denominator. So I'm going to go back to the top and I'm going to see what I'm missing. The first fraction is missing a cosine x in the bottom. So I'm going to put another cosine x in the top as well. The second fraction is missing the 1 plus sine x in the bottom. So I'm going to have to put a 1 plus sine x in the top as well. When I do that, the first fraction's numerator is cosine squared x. The second fraction's numerator is 1 plus sine x squared, two of those. So again, I got common denominators. Now, the next thing I'm going to do is go ahead and I'm going to multiply out this 1 plus sine squared x. I need to get rid of these parentheses here, so I'm going to have to multiply this out. I'm going to use a little rectangle. Now I'm going to write over here on the right side of the board. And I'm going to have 1 plus sine x and 1 plus sine x. When I multiply, I get 1 sine x, another sine x, and a sine squared x. So that's going to equal 1 plus 2 sine x's and a sine squared x. Let's go ahead and replace that in our fraction. Cosine squared x plus 1 plus 2 sine x plus sine squared x. All over. And we'll just leave our denominator the way it is for now. Now, somebody's probably wondering, why am I not going to multiply that together? Let's think back to our goal for 1 second. Our goal is secant. Secant is 1 over cosine. I have a cosine in the bottom right now, so I'm pretty close. I'm thinking I need to somehow get rid of this 1 plus sine x. If I can get rid of that 1 plus sine x, I'm that much closer to secant. So let's look at our top again. Is there anything we know that we can replace? And I see sine squared and cosine squared. Now whenever I see sine squared and cosine squared, I always think of this Pythagorean identity 1. I'm going to replace this sine squared and cosine squared. I'm going to replace these with a 1. They equal 1. If I do a little simplifying now, I get 1 plus 1, the original one I had, so 2 plus 2 sine x on the top. Remember to have your highlighter ready and highlight where you get lost. I took sine squared and cosine squared and turned it into 1, and then I added 1 plus 1, and that's where that 2 came from. Now, that whole thing is still all over 1 plus sine x over cosine x. Remember, we said that we want to leave this cosine here. We don't want to get rid of this cosine because of our goal of secant. I also see a 2 involved, and I need a 2 secant, so I need that 2 to stay in the numerator. The problem is that it's right now 2 plus 2 sine x. I'm going to factor the 2 out of those pieces because it's the same. And remember, factoring out the greatest common factor is one of our guidelines. What am I left with if I factor out a 2? I'm left with 1 plus sine x. And I'm getting excited. Is anyone else getting excited? Does anyone else see something that's going to cancel? Something we said we wanted to get rid of? I hope you see this 1 plus sine x's are going to cancel. So now I'm left with 2 over cosine x. And cosine x, 1 over cosine x is the same thing as secant. So I'm going to rewrite this as 2 secant x. And if we go up here for a minute, that's our goal, 2 secant x. We just made that happen with a lot of algebra involved. All right. We are going to verify one more identity for today. We're going to do one more example, and I'm going to go ahead and bring up a different example than this one. We are going to start with 1 over 1 plus cosine theta plus 1 over 1 minus cosine theta. And I want to verify that that equals 2 plus 2 cotan squared theta. Now, the first decision that we need to make is which side to start with. We're going to start with the left-hand side, the fractions, because remember, one of the things we often do is add those fractions together. In order to add those fractions together, we need common denominators. Now, I think the common denominator is going to be 1 plus cosine theta times 1 minus cosine theta. So that means the first fraction is missing the 1 minus cosine theta. The second fraction is missing the 1 plus cosine theta. So my numerators are going to have a 1 minus cosine theta and a 1 plus cosine theta when I add them together. If I keep adding a little bit more on the top, I just get 2 because the cosine thetas cancel out. Now, this time around, let's try to multiply these together because I'm not going to have anything to cancel out with the top anymore. The top just has a 2. So let's multiply 1 plus cosine theta and 1 minus cosine theta. I'm going to use a rectangle over here on the right side. And we're going to multiply these together. I'm going to get 1 cosine theta, negative cosine theta, and negative cosine squared theta. So 1 minus cosine squared theta, those are going to cancel out. I need to try to decide where to go from here. Now remember, we said we can't split up the denominator. I can't put that as 2 minus 2 over cosine squared theta. It'd be nice if I could. But I see part of our Pythagorean identities here. I think cosine squared theta If I subtract that from both sides of this first Pythagorean identity, I think sine squared theta equals 1 minus cosine squared theta. So I'm going to go ahead and rewrite this as 2 over sine squared theta. I just used that Pythagorean identity. Sine squared. Sine squared is the same as 1 over sine squared in the denominator is the same as cosecant squared. Let's bring the sign up and rewrite it as cosecant. Now, I'm trying to get to cotan. How is that going to help me? How is cosecant going to help me get to cotan? And I hope that you're noticing another Pythagorean identity here, 1 over cotan squared. Let's replace cosecant with 1 plus cotan squared. And are you getting excited? I'm getting excited because when I factor that 2, distribute that 2, I get 2 plus 2 cotan squared. And that's what I was looking for. That's going to end our examples for today.